Today we want to look at the midpoint formula. We want to derive the midpoint formula. The midpoint simply means the average. We want to find the average of the x and the average of the y axis. So that's basically what it means. Now, if we look at this, we have the two-dimensional plane, the x-axis and the y-axis. Now, this is 0. I can take this point as x of 1, and then I'll move along and take this point as x of 2, and then the middle will be x, which is the average of x of 1 and x of 2. Now, if I project this to this line, I have to have a line segment, and then I'll project it to the y-axis. Then this is x of 1, so I'm going to have y of 1 here. So so this point now is a meeting point for x of 1 and y of 1, so I'm going to write x of 1 comma y of 1. I'm going to do the same thing here for x of 2. This is the meeting point, and then if I project this here, I'm going to get y of 2. So the meeting point, let me call this B. So I have x of 2, comma y of 2. Now, then this is the middle. If I project it down to this point, let me say I have C. Now, this is x, and then if I project it to the y, I'm going to get y. So the midpoint, which is C, will be x, comma y. Now, what I need to do, I'm going to form a right angle triangle by joining these 2 points A and B together, and then I'll do the same thing here as well. Now, let me call this A, B, C, D, E. Now, I want to find the distance. Okay, let me call this F. This point is F. I want to find the distance between x of 1, the distance between x and x of 1. So if I do that, I'm going to get x minus x of 1, so x minus x of 1. If I do the same here, the distance between x and x of 2 will be x sub 2 minus x. Now this line, this line is parallel to this line, so that shows that FD is also x sub 2 minus x. YAS is the same thing as x minus x of 1, because this line and this line are parallel, so I'm going to write x minus x of 1. Then on the vertical axis, I'm going to look at this. I want to find the distance between C, E, and D, and the distance between D and E. Now, if I look at this, y sub 2, y minus y sub 1, I'm going to put it here, so y minus y sub 1. I'll come to this side. I have y here, and I have y sub 2. So the difference will be y sub 2 minus y, so I'm going to plug it here. Y sub 2 minus y. Now, I want to find the midpoint. So what I need to do, I'm going to equate because A, from the distance between A, F, is equal to the distance between FD. So I'm going to say distance A, F equals to distance FD. That's on the vertical axis, on the horizontal axis. So AS is x minus x of 1 equal FD is x sub 2 minus x. Now I'm going to take like terms. I'm going to bring x to the other side, and I'll take x of 1 to the other side. So I have x plus x equals x of 2 plus x of 1. X of 1 has to go to the other side. So if I add x because x over here 2x. So I'm going to write 2x equal to x of 2 plus x of 1. If I divide both sides by 2, so x will be 1/2 x of 2 plus x of 1. I'll do the same thing here on the vertical axis. So I'm going to write on the vertical axis. Now, BE is equal to ED. So I'm going to write BE is equal to ED. Now I'm going to equate what I have in BE, which is y sub 2 minus y equals ED. I have y minus y sub 1. So I'm going to take y to the other side. So I have y sub 2 plus y sub 1 equal y plus y. So y sub 2 plus y sub 1 equals 2y. So y will be half y sub 2 plus y sub 1. Now you can see that. So the midpoint simply means the average on the x-axis and then the average on the y-axis. So therefore, I can come out with a formula for midpoint. Now this is the general formula for midpoint, the general formula for midpoint. Now you can see that my midpoint here is C, which has x, y. So therefore C will be, now x is actually 1/2 x of 1 or x of 2, anyone, x of 2 plus x of 1, comma, 1/2 y sub 2 plus y sub 1. So this is the derivation for the midpoint. This is the midpoint derivation. So thank you for watching my video. Always subscribe on my